perspectives on how COP30 has worked. So let me begin with a summary then of our Centre for Climate Repair. We're pretty interested in the Arctic. The Arctic is melting fast, and that's what we want to focus on. But we've got to stop emissions first. Emissions reductions are key. So we've got our sort of 3 R's in the Centre for Climate Repair: emissions reduction, greenhouse gas removal. We've got to get CO2 out of the atmosphere. And but the third one is the thing, well, supposing we don't manage greenhouse gas removal and emissions reductions fast enough, then can we do some stuff relating to actually actively refreezing the Arctic? If you don't know already, the Arctic is, we know we're about 1.5 degrees warmer on the Earth, but the Arctic is maybe 4 degrees warmer on average. So this is Arctic amplification, and well, that's what we're stuck with. And again, just as a reminder really, why is the Arctic important? Well, the ice in the Arctic reflects sunlight, which is important to help to keep things cool. The Arctic Ocean, underneath the Arctic in the permafrost is methane, and methane as a greenhouse gas when released is a potent greenhouse gas. The Greenland ice shelf is melting, and it's perhaps got 6 or 7 meters of sea level rise locked up in it. Certainly we're expecting not all that to happen all at once, but in the next few decades we're really worried that Greenland ice will contribute strongly to sea level rise. And we've seen weather patterns have gone completely wacky as a result of changes in the Arctic. I'd like just to show this visualization if you haven't seen it before. It just gives you an idea of how much ice, this is the floating sea ice, how much of the floating sea ice have we lost already. Now, if this is a drink that you might have with some ice in it, you've got your glass of lemonade and you watch the ice in it melting. At what point do you say, oh, can I have some more ice, please? Maybe sometime around then you'd say, I need more ice. Well, unfortunately with the Arctic, we can't just go and put more ice there. We have to figure out how to refreeze it. That red line in the graph behind, and this is the line, the red line down the bottom, is heading down towards 0. And we can't, it's noisy data. We don't know where to put the line. There's a couple of other lines. One is the amount of ice in the midwinter, and the other is the amount of melt from winter to summer. Where those two lines cross, well, I mean, it's soon. And our children, grandchildren, great-grandchildren won't care terribly much whether that's 2029 or 2034 or 2040. It's going to be sometime soon. And it will have happened on our watch, which is why we really need to be thinking about being responsible for future generations. Some things have happened in the last few years. The regulations for shipping have changed. Back in 2020, the International Maritime Organization stipulated that sulfur dioxide emissions should reduce, and that is the graph showing the sulfur dioxide emissions, and they suddenly went down in 2020, and since then the oceans have been warming up. Now, the people are doing research, particularly I highlight James Hansen. If you want to follow James Hansen's work, he really is highlighting the fact that emissions from shipping is quite possibly telling us a lot. The fact that those emissions have gone down tells us what we can expect in the future. Where are we heading in the future? Well, emissions have been going up and up and up and up, and all the things like, the Great Depression and oil crises, that just hasn't slowed things down. We've got to get our emissions down, yet we tend not to really quantify how much we mean. The amount we need is of the order of 5 tons of CO2 per person. But if you think about our everyday things, the amount of rubbish, trash that my household generates is maybe a whole household is only half a ton per year. Yet CO2 is much more important to our climate. My own, when I flush the toilet, there's maybe a couple of 100 kilograms of poo a year is what I'm responsible for. And people get really annoyed if my dog poos on the park. I'll get fined for that, but I don't get fined for putting tons of CO2 into the atmosphere. So we've got to think about that. There's a neat little way of thinking about climate change, and Clara, who's speaking later, is going to speak more about this. It's a thing called the napkin diagram. I've got my napkin. I always carry a napkin around with me. And the napkin diagram is saying that business as usual, temperatures are going to rise. Emissions reductions alone, temperatures are still going to rise. Carbon dioxide removal as well, temperatures are still going to rise. We've got to do something, and that's where this solar radiation management comes in, geoengineering. And we've got to think a little bit about, is it a responsible thing to be doing? And we'll talk more about that later on. Solar radiation management, solar radiation modification, sunlight reflection methods. This SRM stands for whatever you might want it to stand for, but it's basically reflecting sunlight. There's quite a lot of ways to reflect sunlight, and what we know is that sunlight, reflecting sunlight makes a difference. On a cloudy day, it's a cooler day, that makes sense. Clouds are pretty good, and we're doing quite a lot of stuff on that. Reflecting from the surface of the ice, let's say, is pretty good. Reflecting from the stratosphere, that's high up in the atmosphere, is pretty good. Reflecting from outer space, well, that's interesting. There's an organisation called Planetary Sunshades, and if you feel like Googling planetary sunshades, you'll find out that Elon Musk has got ideas for how we might use the... he's exploring ideas for going to Mars, but on the way, maybe we can help to cool the planet. Anyway, it's a bit creepy. So let's think about this one particular area, which is called marine cloud brightening. And we've got a substantial group of people who are working on marine cloud brightening. There's a few of them over there. Put your hands up, the marine cloud brightening people. There we are, look, them over there. Marine cloud brightening is interesting because we know that clouds reflect sunlight, but they also act as a blanket to keep heat into the earth. You've noticed that at night time. If you've been camping at night time and it's cloudy, not so cold, but when it's not cloudy, you get cold. The physics of clouds, just look at all these complicated terms, hygroscopic growth, collision coalescence. It really is, no kidding, cloud physics is complicated. So what we're trying to do really is to say, well, what experiments can we do to try and figure out how we can understand clouds? So if we go out on a boat and spray seawater, and it turns out that nature does this, spraying seawater. When waves break, you get seawater spray. And that seawater spray makes its way up into the clouds. And the little salt crystals that are inside the seawater, those salt crystals nucleate clouds. Now, nature's nucleation of clouds works very well. That's absolutely fine. But then after a bit of time, when the weather gets nice after a storm, the clouds begin to disperse and there's no more clouds left. But if we can keep nucleating by keep on spraying salt water, we can make the clouds last for longer. Perhaps we can make the cloud droplets a bit smaller, make them more reflective. So if we can brighten marine clouds, then that's perhaps quite a useful thing. That's why it's called marine cloud brightening. It's not about marine cloud seed. We're not trying to make clouds out of nothing. We're trying to enhance clouds that already exist. Now, we kind of know this works because these ship tracks that are no longer happening as much as they used to because the sulfur dioxide has been removed from the fuel. We can see these from satellite images as ships move over the oceans, and we can see where ships have been because they nucleate these clouds. Now, in Australia, at the Great Barrier Reef, the Great Barrier Reef is suffering. There's coral bleaching because the oceans are warming. Now, what can we do about warming water? It's a bit tricky to know what to do, but one thing perhaps we can do is to try to maintain cloud cover over the waters around the Great Barrier Reef. So this is a picture of a boat which has been sailing around the Great Barrier Reef and spraying seawater as a spray to make droplets which turn into salt crystals which go up into the clouds. So this is work that's happening in the Great Barrier Reef, and it's kind of not too controversial there because everybody loves the Great Barrier Reef, and everybody, including the indigenous people, the Aboriginal people in the Great Barrier Reef, are saying, yes, please, let's do anything we can to save the Great Barrier Reef. But there are questions about, cooling the planet. How would you scale this up? Well, there was a guy, Stephen Salter, quite a good name for marine cloud brightening. He was a real pioneer, sadly died last year, but back in 10, 15, 20 years ago, he was not just talking about this as a general topic, but he was doing the sums and coming up with designs of vessels that could deliver the appropriate amount of stuff. Now, one of the things that we're doing here in the department and elsewhere in the university is trying to figure out, do the sums, can this be scaled up? So Stephen came up with some numbers and said, oh, this is how much power these boats would need to consume and the droplets that they would produce. So quite technical stuff. But then basically he was saying, oh, we might need about 1,000 of these boats. Now, that's what he was saying 15 years ago. So over here is the stuff that Stephen Salter was saying. And then over here, well, this is based on information that you get if you go to conferences and things from the people from the Great Barrier Reef. They'll say that this is kind of what we're doing with some. Everything kind of matches. It looks like, hey, whoopee, this is really good. Except for spray rate. This is from one boat. Stephen Salter was reckoning we could get 30 kilograms per second of spray out of a boat, but we're really only getting a fraction of that. So we're maybe 300 times too small. So scaling up is a question. Now, then you might say, we're running out of time. We've got to be doing this quite quickly. Where might we be in 2040, let's say? Well, Stephen Salter reckoned that we only need a 1% change in albedo of the clouds. So we don't have to make a huge change. But even then, when you do the sums, you reckon we're going to need to pump about 1 billion tonnes of water out of the sea per year. And you think, God, that's a ridiculous number. 1 billion always sounds like a big number. But it is quite handy to compare it with other things. Global desalination plants around the world. At the moment, 1% of the world's drinking water comes from desalination, and that's 40 billion tonnes of water per year. So you think, oh, that's easy enough. We can do 1 billion tonnes for cloud brightening. The only problem is that the desalination plants are on land. You can make them as big as you like, and you can run them with solar panels, which are on the land. To scale up to cool the planet by anything as significant, we might need 300,000 of these Great Barrier Reef vessels, all with their own desalination plants. And so things are tricky. Water needs to be filtered because seawater is full of, even clean seawater is full of stuff that's going to block any nozzles that we might want to spray out of. The desalination people have figured all that out. But the desalination plant filtration units are huge. You can have a look at them online. They're massive things. Seawater properties vary depending on time of year and all sorts of things that, if the oysters are ovulating, they'll produce stuff that changes the properties of seawater. And different places in the world have different susceptibility to clouds. And maybe the Great Barrier Reef has been a good spot to go. But if you wanted to go somewhere else, which wasn't such a lovely, pristine, pretty place as the Great Barrier Reef, would the local people be happy for you to go and spray stuff around? Well, that's not obvious. So the opposition to any kind of research or experiment is often to be found. So maybe you want to do regional things, little things, rather than to try to go global. But we're running out of time. So these are really questions about governance and ethics and perceptions. And Clara will be telling us a little bit about that in a second. So I would say that marine cloud brightening can be scaled up, but power requirements and just scaling up by 2040 is going to be tricky. But we mustn't be despondent because we've got to figure this out, and that's why we're doing the research. And just to finish, I want to cover a couple of other things that we're working on. This is on ice thickening. And Jacob is to be found often up in the Arctic with his pumps and looking at how we can thicken the ice. Wow, this is fantastic. This is the kind of stuff we're doing here. Then this is another project which we were working on a while ago, the SPICE project, stratospheric aerosols. And Mount Pinatubo, when it erupted in 1991, sprayed aerosols and it caused cooling. Can we emulate that? So we thought, all right, we'll try and engineer our way into doing stratospheric aerosols. Well, that's all well and good, but then our test gets cancelled and it's deemed to be controversial. And why is it controversial? Surely we're doing good things. Well, we try our best to do good things, but the world around us is not a simple place. And I'm now going to hand over to Clara, who's going to tell us some stuff about the governance side of things. I do want to mention, by the way, earlier this year we had a conference, the Arctic Repair Conference, and I just want to say, just to report on it, it was fantastic. So do keep an eye out for things that we're doing in our Centre for Climate Repair because there's lots of fun things happening. So thank you for my part, and I'm now going to hand over to Clara. Will she use the same thing? So Clara is a PhD student, just started, but has been working for a number of years on just deliberation about solar radiation management, making sure that, well, you'll be talking about all that. So,
thank you. I've never used this microphone before.
And that's the left and right.
Okay.
Yep.
Thanks, Hugh. Hi, everyone. So nice to see all of you here. Like Hugh said, I've just started a PhD here, but I've been working in this field for the past 4 years. I've first heard about it 7 years ago in a lecture, just like some of you. It might be the first time that you're hearing about it. And it really shocked me that 7 years ago, just like today, in a way, it's still not something that's mainstream out there in the climate community. And I had already been working with climate and environmental governance more broadly. And yeah, it really surprised me that there were scientists from all around the world that were looking into something that, for me and many others, it's so controversial. And I wondered why we didn't have more people working on this. And so that's why I decided it was something I wanted to dedicate my time for. So, like Hugh said, I'll be talking a bit about the governance, how difficult and challenging it is, but also some considerations on ethics and justice that might be interesting to some of you. Well, the famous napkin diagram Hugh has already showed, but that's basically to say that we already know, and today it's even clearer than when it was when the napkin diagram was created, that even if we cut all emissions today, there is still a residual warming effect that might be critical. It might be the life or death situations of some environments, like the Arctic, but also the Great Barrier Reef and other corals all around the world. So that's why some scientists and civil society groups think there's a moral imperative into looking at these technologies, because we know that even in the best case scenarios in terms of decarbonization, we might still have those unintended climate impacts. Like I said, it's a small but growing field, especially compared to 7 years ago when I first heard about it. And it's been receiving a lot of attention in the media. Maybe that's how some of you heard about it for the first time. And by attention, I mean both negative and positive comments about experiments, but also startups that are appearing in this field. And I unfortunately won't have time to touch on all of the events that have happened in the past years. But that's just to give you an idea that it's a topic that's coming more out there in the public, not just in the climate community, but just in global news. In terms of intergovernmental or global bodies that are looking into it, we've had a couple of examples. These are just some from 2023. I feel like it was a year where we had different UN bodies, but also just ethics councils publishing things about it. Just yesterday, actually, the IUCN, International Union on Conservation of Nature, they published a policy recommendation after their conference in Abu Dhabi, saying that the IUCN should be trying to develop a policy framework for geoengineering. I didn't have time to include it in the slides, but that's just so you can understand that it's very timely. And the first one, for example, the One Atmosphere report, it came out in February, March 2023, and at the time I was there in Australia with the Marine Club writing team that Hugh mentioned, and it was very interesting to see that their research team was mentioned quite a few times in the report, but the research team didn't know about it because there is this gap in terms of communication between the scientists and the policymakers who are looking into this. But hopefully that's starting to change. Countries, the UK especially, have been looking into this. By looking, I mean putting a lot of money into research. Hugh mentioned ARIA. The Center for Climate Repair, I believe, has received also a grant from them, and that's a huge signal for countries around the world to also try, if not by putting money into research, but just encouraging universities and different organizations to take this matter seriously. And like I mentioned, there are also other players like the private sector who have been entering this field, and this can be, if you look at it through a more critical lens, very problematic if the final goal of doing research from a startup is profit, because then it means you would want these technologies to be used for longer, and that's definitely not something that we want. But also on the other hand, we might need the private sector just to scale up innovations faster, because we know we have to adapt ships and planes and you name it, pumps, so that these technologies can work in real life. And also Hugh touched a bit on outdoor activity. It's been growing. It doesn't mean that it's always successful, but there are some lessons that we can draw from both the positive and the negative experiments that have been happening around the world. Some of the challenges, we have lots of challenges, but these are only some. It's still very global north centric, and we know that when we talk about climate vulnerability, most of the communities are located in the global south, and if one of our main reasons for conducting research is to help those climate vulnerable communities, then we should also have them being more active in research. We don't really have a clear governance framework for it, and it's not because we don't have ideas of how it could work, we just don't have the formal structures that would be able to inform and to actually act on governing these technologies. We have a lack of civil society involvement, and we know just from other scientific areas how important it is to involve people in the research process, especially for technologies that are contentious like geoengineering. But that's something that I do in my work, and it's also something that I'm bringing to my research now, is how can we meaningfully engage communities at large? Not just in the research, but in thinking about these technologies. And again, like I've said many times, it's a deeply contentious field, and that's for several reasons. Some people don't like even talking about it because I feel like it's a way of already accepting that we failed in climate action, but also just being resistant to technology and thinking that there are other ways that we can tackle the climate crisis without relying on technologies, but also religious concerns, for example, of not wanting to have humans interfering in nature, even though we have already interfered a great deal. But yeah, I'm sure you can think of other controversies that come to mind when we're talking about this. And then here, I only wanted to mention as well that when we talk about governance, there are different layers, right? Like you can do a small consultation in a classroom, that's already a form of governance, but there's also the macro scale of the UN, or creating a body that has even more power than the UN. So you have those different layers, but also in the way you approach governance, I think especially for us being here in Cambridge, it's very important to talk about research governance. We also don't have clear guidelines into how research should happen. We have best practices that could be followed. We have organizations like AGU, that's the American Geophysical Union, that just published last year an ethical framework into how to conduct research, but there's no enforcement, right? So at the end of the day, it's still up to a research lab or a country to execute research the way that they see fit, and this can raise lots of problems if you have an asymmetry of perceptions in terms of what's ethical and what's not. But then also for deployment, and I think it's very important to stress as well that talking about the governance of deployment doesn't mean that you're enabling the deployment. It can also mean building a system to ban and to actually account for actions from countries. I feel like when people hear the word deployment, they immediately associate with using the technologies, but governance can also mean how not to use the technologies. But still, we would need countries, and not just countries, but companies and different stakeholders to be in the same room, and we know how challenging it is. We've had the climate conferences for years, and we're still in this situation, right? But then also, because I've touched on public participation, I thought it would also be important to mention inclusion, because you can, for example, invite people to a meeting just like this one, or to an informal town hall, but we know there's also a lack of inclusion of different groups that are usually marginalized in communities. And so, especially for technologies that are new like this one, how can we make this different and in a better way that actually brings everyone on a same level of understanding? And then I'm running out of time, and I know I want to hear questions from you as well, but I believe, and many colleagues as well, that climate justice should be the base for any discussions on climate repair, because otherwise we would just be reproducing patterns, not only in climate, but in in so many other technologies where if justice is not the center point of the issue at hand, you just get lost in other things like profit making or just geopolitical issues, and you kind of end up missing the point of why you're doing that in the first place. And inside justice, we can also talk about human rights, and there are so many different layers of human rights, but just to name a few. So when it comes to procedural human rights, so in the actual process of designing these technologies and implementing them, are we making sure that those human rights are being respected throughout? But then when it comes to substantive or like the basic human rights, how are geoengineering technologies impacting those? Because we know there are, so Hugh didn't mention, but we know there are good impacts that can come from these technologies, but also negative ones, like maybe it would increase the amount of drought somewhere, whereas another place would struggle with more floods. So we would have all of these different things happening at the same time, and then how is the access to basic human rights impacted? And yeah, I think I'll just skip the slides on good governance, but that's just to say that we have different elements that can help us understand what good governance means. And I think I'm just going to touch on the last one, that we make sure that it's aligned with the climate response portfolio. Another big reason why lots of people don't want to talk about geoengineering is because they think it would be distracting us from the actual solution, which is, as we know, decarbonization and changing different systems that we have at hand, like changing the way that capitalism is, for example. And so it's very important that whenever we're talking about climate repair, geoengineering, we don't lose the focus. There's been research that shows that looking into geoengineering doesn't mean that you would be decreasing your commitments on climate action. It's just something that has to happen in parallel, and it's always important to stress that as well. Just because we're talking about this doesn't mean that we don't think that decarbonizing is still like the highest priority. And then to finalize, I guess some three big gaps that we still have in governance. First is the knowledge asymmetry, like I mentioned. Some groups, and I think this is a common thing around the world, right? Some groups have more knowledge than others, but when it comes to a technology that will ultimately impact everyone, we have to make sure that we counter that gap. In terms of participation, not just at an individual level, but how can we bring different sectors, so not just academia and governments, but how can we have a plural environment looking into this together? And then for decision making, we can't wait until the technologies are developed to start thinking about the frameworks that will regulate them however we decide to. And so it's also something very important that we should be looking at. And like I said, there are different bodies that are looking into this, but we don't have just one big forum where this can be properly addressed. I'll skip that one, and just to finalize officially now, Hugh said that there have been some experiments that have been canceled, and the common trait that all of them have, for the ones that have been canceled, is that they did not engage with the public. Unlike the case in Australia, where I know not just from what is out there in the media, but because I was also there in person, I know that they were engaging not just while they're doing the research, but before. So they have not just consulted, but co-designed the experiment with the locals, but also in the case of the sea ice thickening experiment happening in Cambridge Bay in Canada, the locals are also involved from the outset. And so maybe that's a good example of how public participation can actually enable the experiment to happen. But then we have examples. So Hugh mentioned SPICE, but there's also the same technology, marine cloud brightening, was started to be tested in California last year, and it was out on the New York Times, but not even the mayor of the city knew about it. And the scientists, they had all of the permits to do it in terms of, regulations there at a local level, but they didn't inform anyone in the community. And even though it wasn't a harmful experiment, they were mainly just testing the machines, if you don't tell people that you're doing something that's harmless, how are you to build that trust from the beginning? And so the locals, they themselves assembled a town hall and were like, we don't want this. And so the experiment was shut down in just a couple of days. And ScopeX was a big stratospheric aerosol injection experiment led by the Harvard University, and they wanted to test it in Sami land, so northern Sweden, but they didn't consult with the Sami before. They, again, had their permits. They weren't going to test anything that would be dangerous, but they didn't engage with the owners of the land. And so it's just as if someone wanted to test something harmless in your background, and they're sure it's not going to harm anyone, but they don't ask for the permission to enter your space. And we've had that example as well of intruding an area with startups as well. So it's not here on the slides, but there's a startup called Make Sunsets, which is from the US, but they entered the Mexican territory and didn't ask for the Mexican government's permission, even though it doesn't say in their constitution that you're not allowed to do a stratospheric experiment. And so as a response now, the Mexican government is trying to ban all research in geoengineering in their national territory. So yeah, again, like I said, maybe this is just a lesson for us, especially as researchers here in the room, on how important it is to actually engage people. And it's a slow process. It's not something that you can do from one day to the other, but the sooner we start, the better. And yeah, thank you so much. And I guess Hugh and I can take some questions now if you have any. Do you want to have the mic back, Hugh?
So I think we've got a roving mic. Look at that. So do put your hand. Thank you very much, Clara.
No worries, thank you.
Do put your hands up if you've got questions. And we've got a question. Yeah, there we go. 2 roving mics.
I've got one question to do with, obviously, like a repeating concern that's coming up is people don't understand, we don't understand the full impacts of what marine carbon bitumen has if we do it on less of a regional scale and on a larger scale. How much work is being done into looking into like the global impacts of something like that? Trying to model that, or in terms of writing reports, like how much of a consideration is that when you're considering these newer ideas for how to do different geoengineering methods?
Well, that's interesting because there's two aspects to it. I mean, global impact. If you do a little experiment and you want to scale it up, kind of an engineering answer to that is, well, you scale it up by building more boats and you do you make it bigger. But in terms of how the people who are living on the planet respond to scaling things up, in a way it's almost a harder question. I don't know what perspective you have on scaling things up and how we should go about it.
But was your question more on the technology itself?
It was more to do with like you've got this technology that you're looking into all these different technologies. What are we doing to ensure that the concerns about when people scale these sorts of things up, what are we doing to sort of answer those concerns or be able to like consult people to say it's not as bad as you may think it is?
Yeah, so I think communication right now is playing a key role. So the first step, for example, training journalists to answer questions that people have after reading a paper. So that's an ongoing work with some organizations. But at large, I think your question reminds me of the reason why I decided to do a PhD. We don't have a forum for continuous engagement with the whole planet. And that's not just a problem for climate repair, but for other things. We just don't have this like planetary governance framework that would like an ombudsman, that would serve as an ombudsman. And I think your question just shows that we have a lot of work to do still.
But I think from a technical point of view, there are conferences on modelling of the climate, and how, so if we did put 1 billion tons of seawater spray, what impact would that have on the climate? And maybe what goes up must come down, so if we spray all this stuff up, and then you get all this salty water that comes down on farmland. I mean, this gets into the question of, it might be fine to spray stuff out in the oceans, and who do you have to consult? If you spray in the oceans, who do you have to consult, given that this salty spray is going to end up over land? I guess you've got to consult the people whose land this salty water's. So understanding the impacts, it's not just about the impacts on the climate, on the temperature. As Clara said, there's rainfall, there's droughts, there's floods, there's all sorts of biodiversity issues. And modelling these things is, there's a lot of people around the world who are modelling the climate impacts, even without doing geoengineering, but climate impacts with and without. And there's a good question about, how do you did mention it, Clara, the idea that we've got to look at what might be the impacts if we didn't do geoengineering versus the impacts if we did. Mm-hmm. And we don't really understand yet the scale of those impacts, but the research is happening.
Great presentations. I'm just curious because I'm also kind of a social scientist, SRM governance person, and I'm just kind of curious what you would want to come out of social science kind of in the near term, either of you, that were kind of in line with what DSG wants and is trying to do, kind of things that social scientists themselves can do, or outputs that they might be able to produce, work we could do that could kind of help open up the space to more conversation and really kind of enable kind of more discussion about all of this.
I think social scientists, when compared to the engineers in this field or the climate modelers, were the minority. But there's been it's a fast-growing field, I guess, for social scientists as well, and it can mean like in law or in philosophy or just history of science. We have more and more people looking into it. But I think they're all important, but something that I'm very interested in is the actual practical governance aspects. And this can be informed by different fields of knowledge. But I'm interested in the improvement of the governance systems that we have. And that's something that we have more and more people looking into it. How can we translate different regulatory frameworks that already exist into this field, but then also can we create new ones and really be creative and think outside the box?
It's really great that you've come. In our future seminars, we really want you to encourage others to come, and others from other departments, other disciplines, bring along friends and family, because I think these are topics that need to be discussed really pretty widely. So in terms of what kind of social sciences engagement work needs to be done, there's quite a lot of the theoretical side, but the practical side of getting people to turn up, and which is why I think it's fantastic that we've got Andrew. Thanks again for bringing along your pupils. Do ask questions. Oh, look, we've got one at the Lee School. Excellent.
Hello, thank you for the presentation. I want to ask two questions, one after the other. So the first one is, I understand that marine clouds are above the water, but how far away are they from the land? So in the reef, right? It's quite near the land, so you could connect the boat to the supplies or energy or whatever. But if they are in the oceans, far away from land, how far away the ship actually needs to be for it to work?
So let me just answer that quickly by saying it's all about the air being quite clean, because once you get near land and where you get just natural pollutants, dust and stuff, and man-made pollutants, there's plenty of nuclei for clouds on the land. So there's not much you can do near or over land. But when you get over a nice clean sea, and over the coral reefs, it's pretty clean. So that's why it makes a difference. But you've got to be away from to make any difference, you've got to be away from the dust. So if you've got, for instance, the wind is blowing in towards the coast, it can be effective because you haven't got the dust from the land. But if the wind is going the other direction, it's not so effective. So they're the kind of complications in the story. But you had another question.
Yeah, so if coming from that, if you need to be quite far away, then those boats need to somehow have energy and stuff to work. So they need some kind of fuel. And if they use fossil fuels, then it's not actually helping. If they use electricity, then they need to get it from somewhere. So I thought, are they being connected to the land somehow to get those energy, or are they just self-propelled by something?
Well, we think about this, and then we stop thinking about it, because that's quite a hard question. But perhaps what we end up having is a fleet of little boats, which are more like drone boats, which are battery operated, and they're charged up from a bigger boat, which is connected to the. We don't know the answer to that, but you're dead right. We can't be powering these boats with diesel fuel. So it may well be wind turbines out in the Arctic. It's pretty windy around in the Arctic. So maybe wind turbine hubs where we can charge up the batteries on the boats. That's the long answer. The short answer is we just don't know.
Thank you very much.
How are we doing on time? We've got a couple more minutes?
Yeah, there's one question there and one here.
Hi, there's, before I ask my question, there's a minor logistical point. The website is showing a lecture on the 27th, Thursday the 27th, which isn't a Thursday.
Yeah, that has now been fixed.
Okay, all
yeah,
right.
it's a Monday. Yep.
Right, fine. And I wanted to ask Clara, if I may, could you flesh out a bit more about what your role with the organisation is and your ambitions within that role, and also what you feel the role of the Deliberation on Solid Geoengineering Alliance is, where it is contributing to the debate. What is it doing that other organisations can't do or won't do that makes your pitch distinctive for your funders, whoever they are? I don't know how you're funded.
So to your first question, I run different deliberative exercises in different parts of the world. So for example, in the Arctic, we've been running futuring and foresight exercises with different communities. That's something that's on hold right now, but it's just to inform policymakers in the Arctic. That's one example. Another thing is organizing workshops with different climate groups from all around the world, and that's very dependent on the interactions that we have with different countries or just different climate organizations. We also have a group for early career researchers. Some of them are here in the room. We're organizing the first conference for early careers next week in Finland. But at large, I feel like my work is dependent on what comes our way as well. So there are countries that are organizing consultations, like the UK, for example, and then we help in informing and advising them, but also just helping to run the process in a smooth way. Or Brazil, where I'm from, for example, they just held their first official conference last week or 2 weeks ago. So we also help them organize events like that. So, I mean, it's a small field and there's so much that any of us can do.
I think I want to add that the Centre for Climate Repair has kind of developed as a sort of a technology entity. And by looking at the technology alone, you don't win the hearts and minds of people who might be interested in taking up the technologies or opposing the technologies. It's been a bit of a weakness in our centre not having a social science centre in our centre. We've got 2 or 3 members in the university now in the social sciences, and so Clara is our newest member. And I think it's really interesting just to, we're wanting to engage with the humanities, but traditionally, humanities funding in geoengineering within the humanities, it's not kind of an obvious thing. So maybe ARIA will be funding more stuff to do with ethics and governance. Well, I know that they are. So.
Yeah, that's still for the future.
Now, I think we need to finish. We got one more question. Yeah, okay.
Thank you very much. I seem to recall when you launched a few years ago, it was reduce, remove and repair. And I wonder whether the change from repair to refreeze reflects a new perception that the portfolio of repair options may be narrower than you had first hoped.
That's very observant, but so we kind of thought that the Centre for Climate Repair, and then using the word repair twice, does that mean that is reduce and remove, are they to do with repair? So it's a bit this. Nothing's perfect. If I had I think we've decided to focus on the Arctic, and so that's why we went down the refreeze route. But there's lots of other things that don't begin with R. So yeah. Well, look, thank you all very much for coming. I'd like to say special thanks for Clara, who's joined us today. Thank you. And we're going to be putting material onto our website, including, I hope, a recording of today's talk, which will include the slides, so you'll be able to refer back to them. So then the next event is
on the 30th. Oh no, the 27th already.
Monday the 27th, which is in Department of Applied Maths, and then following up on Thursday the 30th will be in here. And do QR code scan and join our mailing list. Thank you all very much for coming.
Thanks, everyone. I love that you have one with you. I love that you have one with you. I have one at home from degrees as well.